Hi class, this is the video for section 3.5, and in this we talk about what we call implicit differentiation. Okay, we'll know what that is, and then we'll use the laws that we have, or the rules that we have studied so far for such functions. Okay, the learning objectives are the following. Use the chain rule to differentiate implicit differentiations, and also we'll talk about the derivative of what? Inverse trig functions, or what we call the arc functions. Okay. The functions that we have met so far can be described by expressing one variable explicitly in terms of another variable. For example, if you have y equal to the square root of x cubed plus 1, this is written in what? Explicitly, right? But in this equation, if I square both sides like that, I'm going to have what? Y squared is equal to x cubed plus what? 1, which could be written as what? Minus x cubed, bring all to one side, y squared, and then minus 1 equal to 0. So when you have such a function, we call this what? This becomes what we call the what? Implicit. Okay? So that's implicit what? Implicit function. And so if we differentiate this function with respect to x, we're going to differentiate it the same as differentiating what that function without squaring it. Okay? So in this function, this chapter, what you need to note is that your y, as you can see, is a function of what? It's a function of x. So y is always a function of x. And so if you want to differentiate it, you have to consider what? The chain rule. Okay. Now, the following are other examples of what? Implicit what? Functions, like x squared plus y squared equal to 25. See, this is the equation of a circle. Okay. And the radius is what? The radius is 5, and then the center is what? At the origin. Okay, that's the center. Okay, so if you have that, we will call that as what do you call it? a circle. And this is the diagram we have. So that's a circle, x squared plus y squared is 25. And then if you take square root of both, solve for y, it's either plus or minus. So when you put this together, you get a full circle. All right. So that is this in this form is what? Implicit. Okay, that's implicit what? Function. Okay, it's not in the form y is equal to what? F of x, like that. And then another example is what we say you have x cubed plus y cubed equal to 6xy. Okay, now in this function they call it what? The Folium what? Folium what? Descartes. Okay, Descartes. And this is how it looks like. All right. So such a function is hard to solve for y, because especially if you have y on both sides of the equation. Okay, how to solve for y. Okay, so that's why it is important to know how to differentiate what? Implicitly. In the sciences and engineering, there are a lot of phenomena where functions that model the situations are expressed what? Implicitly. And therefore, we must be able to handle that, or those such functions. All right. So fortunately, there's a way to go about this, and that is what we call, I said, what that's called the implicit what? Differentiation. Now, always observe, as I mentioned, it's a function of x. So if you have y squared, it's a composite function, and therefore we use the what? The chain rule for that. Now, with this said, note the following, very, very important, because we'll be encountering them or we'll be seeing them very often. So first one is that if you have a function, generally speaking, right? If n is a real number, for any real number, if you have y equal to what? Y raised to n, if you differentiate that, remember, the y is a composite function, okay? Y is what? Is a composite what? Function. Now, if it's a composite function, then we can use a chain rule. And that is what? If you differentiate, you have for n times y raised to n minus 1. And because the chain rule, we multiply by what? Dy dx. Now, either we write dy dx or we write what? Y prime. And that is what I have this one. Okay, so sometimes I'll be writing dy dx, or I'll use what? just y prime, and you know that they are the same. Okay. The second thing is that if you have a function like this, say x times y, notice that this is a x is a function and y is also a function of x. So that's a product, okay? Product of what function? That's why we use the product rule here. And so if I use a product rule, keep the first one, differentiate the y, which is dy dx, plus keep the y and differentiate the x, which will give me 1. So this is basically y times 1, which is y. Or if I write in terms of y prime, then it's going to be what? The dy, the x becomes, it's just same x, and then dy dx is just y prime. So basically it's what? The same as saying that this is what? X times y prime plus what? Plus y. Okay. So that is another thing. Whenever you see x times y, or if you even if you see x squared times y, if you want to differentiate this, okay, with respect to x, you have to use a product rule on that. Okay. Another one is that if I have dy dx, if I differentiate dy dx, I get a second derivative. Okay, you get a second derivative. So don't think that if you differentiate it, it's not the same as what? Dy dx all squared. So if you differentiate that, okay, dy dx, this is what just what d square y over dx squared, or which is the same as differentiating the y prime, which will give us the same thing. Or better put, this is what? Y prime prime. Okay? Now, the fourth one I want you to know is that these are not the same. The left-hand side is not equal to the right-hand side. Okay? This is what? The second what? That's the second derivative. Whereas that is what? Square of the first derivative. Okay? The square of the first what? Derivative. All right. So we want to take the examples that I showed you, those the circle and then the following what? The Cardis functions. I want to differentiate them implicitly for you to see. Okay. Now these are the steps. Now what you do is that differentiate both sides of the equation implicitly using all the rules that we have learned so far, including what? Especially the chain rule. Okay. And then when you finish, the second step is that solve for what? Either y prime or dy dx in step 1. Okay. So here comes some examples. First, remember this circle, x squared plus y squared equals 25. We want to find dy dx. And then B, we want to find the equation of what? Equation of the tangent to the circle at the point 3, 4. Okay, well, the steps, as you can see, we want to differentiate this function. Okay, you have dx plus y both sides. Now, which the operator will what? We can spread it over, which will be what? The derivative of x squared plus the derivative of what? Y squared. Now, if I differentiate a constant, I get 0. So what's the next step is that if we differentiate x squared, you get what? 2x. Now, if you differentiate y, remember y is always what? A function of x. So what do? We use the chain rule. Okay? So don't forget. So if I differentiate y squared, I get what? 2y, then 2 raised to 1, then times what? Y prime. Always you multiply by y is equal to what? 0. So basically this is what? 2x plus what? 2y, y prime equal to that. Then we are solving for y prime. That's the step 1. Okay, this is what? This is step 1. Now step 2, it says what? Solve for what? Y prime. So if I solve for y prime, subtract 2x from both sides, I get what? 2y, y prime equal to negative 2x. Then divide both sides by 2y. Okay, then have what? Y prime is equal to negative x over what? Over y, because the 2's will cancel out. Okay, so this is the what? My derivative, which is represent the slope of the tangent to the circle at any point. So part B says that we should find the slope, the equation of the tangent at the point what? 3, 4. It means that x is 3, y is what? Y is 4. Okay. So finding the equation, now we know that y prime, which is the slope, okay, the slope of the tangent, m is equal to y prime, which is what? Minus x over what? Over y. Then we want to evaluate this at what? X equal to 3 and y equal to what? 4, because of the point that. So that is equal to what? Negative 3 over what? Over 4. So at this point, 3, 4, what is the equation of what? Of the tangent. The equation will be what? Y minus 4 equal to negative 3 over 4. Then x minus what? Minus 3. Of course, if you simplify this, you have minus 3 over 4 times x. Then we have plus, will be 9 over what? Over 4. Then have y minus what? 4. So that gives us y is equal to minus 3 over 4, x plus what? 9 over 4 plus what? Plus 4. Now, if I simplify that part, this is going to be 9 plus 4 plus what? 16 over what? Over 4. That gives me 25 over what? Over 4. Y equal to negative 3 over 4 what? X. So that is the what? The equation of the what? Of the tangent at the point 3, 4. Okay. All right. Now let's do the following work. Discourage a function. Okay? We want to differentiate that implicitly, and again, we want to find the tangent. Okay. By the way, this is example 2 in the textbook. Okay, on this page. So on page 210. Now at the point. So basically, we need to find the slope of the tangent. So first, slope of the tangent, m is equal to what? Y prime. Okay, evaluated at x equal to 3, y equal to 3. All right. So we want to differentiate step 1, so differentiate that implicitly. So we're going to differentiate dx of x cubed plus the derivative, both sides of the equation, of y cubed, then equal to the derivative of what? X, then 6x what? 6xy. Now, if you differentiate x cubed, please, that is the normal power rule, that x what? 3x squared. Okay, 3x raised to 3 minus 1. That's why I have the square. Then plus, this is you use what? Y is a function of x, so you differentiate it using the chain rule. So that is what? 3y, 3 minus 1, which is 2, then times what? Y prime. Okay, now when you come here, remember x times y, it becomes what? It's a product. Okay, that's a product of what? 2 functions. Therefore, we use the product rule on that. So let's keep the 6x and differentiate the y, which will get what? Y prime. Then plus, keep what? The y and differentiate what? 6x, which will just give me what? Just give me 6. So this is equal to a 3x squared plus what? 3y squared y prime. Okay, that is equal to 6xy prime plus what? 6y. Then we solve for what? Step 2, solve for y prime. Okay, what is y prime here? So we bring this, we move this to the left and take this what? To the right. So that gives us what? 3y squared y prime, the minus 6xy prime is equal to 6y minus 3x squared. Okay, then we factor y prime from this, the expressions on the left hand side. So factor y prime out, you get 3y squared, okay, the minus 6x is equal to 6y minus 3x squared. Then we divide both sides by 3y squared minus 6x. 3y squared minus 6x. Okay, now which will simplify into the numerator, factor 3 out, you get 3, and you get what? 2y minus what? Minus x squared. And then the denominator to what? 3, and that is y squared minus what? 2x. So my y prime, okay, this cancels that. So y prime is basically what? 2x, sorry, 2y minus x squared divided by y squared minus what? 2x. Okay, the 3's will cancel out. Okay, now the slope, which is the m, is a value. It is this expression here evaluated at what? X equal to what? 3, y equal to 3. Why? Because at this point, the slope at what? At the point what? 3, 3. Okay, so this gives us, okay, which is what? 2y, okay, let's write this again. That's the x squared divided by y squared minus 2x evaluated at x equal to 3, y equal to what? 3. Now, what will this give us? This is 2 times 3 minus 3 squared over 2 times 3 minus, sorry, it'll be 3 squared minus what? 2 times what? 2 times 3. So that gives us 6 minus what? 9 over 9 minus 6. And that gives us actually negative 3 over 3, which is what? Negative 1. So therefore, the equation of the tangent will be what? Y minus, at this point, okay, 3, 3, and the slope is what? Negative 1. It's going to be y minus 3 equal to negative 1 times x minus 3. And that gives us y is equal to negative x plus what? Plus 6. Negative, right again, negative x plus what? Plus 6. So that is the equation of the what? Of the tangent. Okay. Okay. So now let's go to the derivative of what? That's a part A of this function. So we got that slope. The second part is that we should find a point, okay, in the first quadrant, okay, where the tangent is what? Is horizontal. Excuse me. Okay. Where the tangent is what? Is horizontal. Now we have our function, okay? We have our function, and then if we find the what? Okay. When the tangent is horizontal, right? It means that what basically means that the what? The slope m is equal to 0, or the y prime is equal to 0. So basically we take that y prime where we got, that is y prime is equal to, it was 2y minus x squared divided by y squared minus what? 2x. Now to set this to 0, what that gives me is that you have 2y minus x squared is equal to 0, because to cross multiply, okay, you have cross multiply, you have that. And it means that the y is equal to what? X what? Squared over what? Over 2. Then we put this into the what? The original equation, which was what? X cubed plus y cubed equal to 6x what? 6xy. So wherever we see y, we're going to put this and solve for what? And solve for x. Okay. So we have what? X cubed plus y cubed, which is what? X squared over 2 all cubed is equal to 6 times x times what? 1/2 x squared. Well, that gives us what? X cubed. And then if you have squared and then cube, that gives us what? X to the 6 over what? 8 equal to what? 6 times. Okay, this goes there. This is what? 3. You can do that. And that gives us what? 3x cubed, like that. Okay, so then let's bring this to, we are solving for x. So let's bring all to one side. So that gives us what? X cubed minus 3x what? Cubed plus x to the 6 over what? 8 equal to 0. Then that gives us what? X to the 6 over what? Over 8 minus 2x cubed equal to 0. Factor x cubed out. All right. And then you have x cubed over 8, x cubed over 8. Let's write again, x cubed out, then x cubed over 8 minus what? 2 equal to 0. Now in the first quadrant, okay, x is not equal to 0. So basically then what is equal to 0? That will be x cubed over 8 minus 2 equal to 0. And that is equal to what? X cubed is equal to what? 16. Okay. Then what is that? Take cube root on both sides over 16. This gives us what? 2 raised to what? 4 over what? Over 3. Because we're going to have what? 16 raised to 1/3, which is the same as 2 raised to the 4, all raised to what? 1/3. That's why I got that. So the x coordinate at the point where in the first quadrant where the tangent is horizontal is that. So therefore, what is the y coordinate? This is the x coordinate. Is that? That's 2 raised to what? 4/3. What is the y coordinate? What is the y coordinate? Well, we know y is equal to this. So let's substitute the x into that and find that. So that is what? 2 raised to what? 4 over 3. Okay. All squared divided by what? 2. So that gives us what? 2 raised to what? That is 4 times that. That is what? 8 over 3. All raised divided by 2. That is the same as 2 8/3 minus 1. Okay, then that will give us 2 raised to what? 5 over what? Over 3. So the point is that it has the coordinates 2, 4/3, and then what? 2, 5/3. This is the point in the first quadrant where the tangent to the curve is what? Horizontal. Okay. All right. Now, there comes what? The inverse functions. Differentiation of what? The inverse functions. Okay. Now, I'm going to prove 1 or 2 of them. And then we have the others, I will give them to you. You can try the proof later. Okay. I recommend you do, because that will help you to understand this concept very well. So you know that definition of what? The arc sine, which is also the inverse sine function. Okay. If you look at the graph of sine, okay, sine 0 is like this, it goes like, okay, which is 0, this is pi. At pi by 2, it's what? Maximum is what? 1. Now, if you have that, it does not pass the horizontal what? It doesn't pass the horizontal line test. Okay, so you say that the whole function doesn't have what? Slope. It doesn't have what? Inverse. Because if it has inverse, it has to be 1 to 1, and it has to pass the horizontal line test. So what we do is that we restrict the domain to between negative. So if you have negative pi by 2 to positive pi by 2, okay, this is pi by 2 and negative pi by 2. The graph goes like this, okay? Goes to 0 and goes like that. So it will pass the what? The horizontal line test. then the inverse arc function sine will exist. Okay. Now, to prove find the derivative of this function, y is equal to that. Okay. When you have this, what does it mean? It means that you want to find the angle whose sine is y. That's the arc sine of x. So it means that sine of angle is equal to what? Is equal to x. Okay. So if I'm going to use a right triangle, okay, using the simple word SOHCAHTOA, okay, SOHCAH and TOH. So since we are dealing with sine, is when we so, okay, so angle of sine y, so if it is y, the opposite is what? X, and then this is over 1. Okay, sorry, this is over 1 here. So that means the hypotenuse is 1. Now, if you use the a or c squared is equal to a squared plus b squared, then this side is going to be the square root of what? 1 minus what? X squared. Because c is 1 is equal to what? X squared plus b squared. And you solve for b, you get that. Okay, so if you have this, then what does it mean when we have this function? Now we want to differentiate the expression sine, this equation sine y is equal to the derivative of what? Of the x. Okay, so implicitly, now this is sine, and if I differentiate sine, I get what? I get cosine. So this is what? Cosine of what? Y. Now, since implicit, we also will multiply by what? Y prime. That is when it's involving y, please. Okay, if you differentiate sine and x, if you differentiate x, you get just 1. Then let's solve for y prime. Then that is called 1 over what? Cosine of what? Y. So that is what we did there, right? This what? Right triangle. Okay. Okay, that triangle here. Because now that I need to find cosine of what x, which is what? Cosine is what? Adjacent over hypotenuse. So cosine, so just say that, but the cosine of y is equal to what? The adjacent over what? Hypotenuse, which is square root of 1 minus x squared over 1, which is basically what? The square root of what? 1 minus x squared. So therefore, my y prime, okay, therefore, my y prime will be what? 1 over cosine of y, which is what? Just the square root of 1 minus x squared. 1 minus what? X squared. So that is our answer. Therefore, if I differentiate this function, the arc sine of x, I will get what? 1 over what? The square root of 1 minus what? X squared. Okay? All right. Now you can do the same thing for cosine, and you get the only thing difference that this will be minus. All right? Okay. So that gives us these following what? That's the one, this is the one I just proved. Okay, I just proved this one. Now, if you do the differentiate the arc cosine of x, you get what? Negative of that. And then tangent will be 1 over 1 plus x squared. And then cosecant, and then secant is that, and the cotangent is, so this is 1 over 1 plus x squared. The cotangent is minus. And these two are analogous, except that one is negative, one is positive. Okay, and these two, the first two, are analogous. Just know one of them and know that the cosine is negative. For tangent and then cotangent, know that of tangent, and the cotangent is what? Negative of the tangent. So these are the 6, what do you call it? Basic inverse word, derivative of the inverse word functions. Okay. Now, this, how do we use, the question is, how do we use these what? This formulas, especially if you don't have just x here, but you have something like what? 2x squared. How does what? The formula differ? Okay. or how different the formula will be if you have something like that. So I want to note this, okay? Now, generally, if I have something like I'm going to write this. If I have the arc sine of, say, u, where u is a function of what? X, all right? That means not just x, then this derivative, d dx of arc sine of what? U is equal to, I'll use the same formula, remember, is what? 1 over the square root of x squared. Okay, the only difference that I'll use a chain rule. It will be square root of 1 minus u squared. So whatever you have the square of that, then times what? Du over what? Dx, using what we call the chain rule. Now, I hope at this time you see the importance of chain rule. Without the 3.4, it will be very difficult to move forward with the differentiation concept that we have learned in 5.5, 5.6, and so on, after chapter 3, and even in Calc 2. Okay, so let's take examples where the function, the angle, okay, like this is not just x, but it's like 2x maybe plus 1 or something else. Okay, all right. Now I know if I differentiate tangent, let me write a formula here. If we differentiate tangent, right, arctangent of what? X, this becomes 1 over 1 plus what? X squared. And so if I want to find y prime, which is the derivative of this guy, the arctangent of what? X squared. All right. So if I use the formula, it's going to be 1 divided by 1 plus the x squared. Now here my x squared is actually x squared. This is this guy here. Whatever I see here comes right there. Okay. Then because it is not just x, it is derivative times what? The derivative of what? X squared. And what would that give me? That gives you 1 over 1 plus x to the 4 times what? 2x. So the answer is what? 2x over 1 plus x to the 4. Okay. Now, let's look at another example in terms of what? Sine. Okay. It is what? 2x plus 1. We use the formula and then what? Chain rule combined. So here, my y prime is equal to, what's the formula for sine? If we differentiate the arc sine, it's what? 1 over what? The square root of 1 minus what? X squared. Okay, so this will be 1 over the square root of what? 1 minus x squared. Now my x squared in this case will be 2x plus what? 1. Then times the derivative of what? That expression. So this is equal to 1 over, okay, the square root of 1 minus 2x plus 1 all squared times what? 2. Well, we can simplify the numerator there, which will give us the square root of what? 1 minus 4x squared minus 4x minus 1. Because if you put it in the plus plus and then you send a negative into, then this is what is going to be 2. So we have what? We have 2, okay? And then when you do this, the positive one and negative one will go away. You're going to have the square root of 4x squared minus, actually, minus what? 4x. Now I can factor 4 out and get something interesting there, which is square root of, if I factor 4 out, I have minus x squared minus x. Now, if you bring the 4 out, the square root of 4, which is 2, so that is going to be, that is my y prime, is going to be 2 over, okay, from here, we go, come to here. You have what? The square root will be 2 times the square root of 4 minus x squared minus x. And those two will cancel out. So the final answer will be what? 1 over the square root of what? Minus x squared minus s as my final answer. Okay? All right. Now, two more examples, and we want to look at this function. If you have this, you have to differentiate these two. All right, so for A, we have what? Y is equal to 1 over the arc sine of what? Of x, which is the same as the arc sine of what? X, all raised to -4. So don't think that this will go up and become positive. This is not equal to sine like that. No, it's not. Because it's the whole expression that you're taking it to the top. That's why it's minus that. So then let's find dy dx. Therefore, your y prime, okay, the y prime is equal to, if I use the chain rule, let's use the chain rule, which will be -1, okay, and then we have what? Arc sine of x raised to what? -2, because we have -1 minus 1, then times the derivative of what? The arc sine of what? Of x. Okay, well, so this will give us -1 arc sine of what? X, all raised to -2. Then what is that? This is 1 over the square root of what? 1 minus what? X squared. Okay, because we differentiate, that's what we get. Therefore, this whole thing becomes what? Negative 1 times y, that's -1 divided by, then this can go to the denominator as what? Arc sine of what? X, all raised to what? Squared, and times what? The square root of 1 minus what? Squared. So that is your answer for what? The derivative of y. And then the final answer, another example is this: arc x times the arc tangent. So this is the same as x times the tan inverse of what? The square root of x. So you see, this is a product of two functions. So we're going to use the product rule. And because that is a square root, we use the chain rule. I hope you get that. Therefore, let's find the f prime of x. F prime of x is going to be the product rule, keep the x, and differentiate what? The arc tangent of square root of x. Then plus, now I keep the what? Arc tangent of what? X, so square root of x. Then differentiate the x. Okay. Now if you differentiate the arc tangent, we have for x times 1 over is what? 1 plus x squared. 1 plus x squared. But here my x is what? Square root of what? Square root of x. Okay. Then times the derivative of what? Square root of x. Okay. And plus, you keep the what? Arc tangent of square root of x. Differentiate the x, you get square 1. So now let's simplify that. Okay, the numerator is x times, if I differentiate the square root, I'll get 1 over 2 x raised to 1 minus, sorry, 1/2 minus 1, which is negative 1/2. Okay, and then divided by 1 plus, if we square root of, take square of that, you get just what? Just get x. Then plus what? Arc tangent of what? Square root of x. Okay, so basically what is happening is that the numerator becomes x, right? Which is x times that, so this is 1. So we have 1 minus 1/2, which is 1/2. So numerator is what? This times 1/2, then times 1/2 over what? 1 plus x, then plus arc tangent of square root of x. So final answer will be, that's my f prime of x. Okay, that's going to be, the numerator will be the square root of what? X, because of x raised to 1/2, then divided by what? 2 times 1 plus x, okay? Then plus the arc tangent of square root of 4x. And that gives us the answer for that. So that brings us to the end of this section. I hope this is helpful, and I'll see you in the other video. Thank you.